Now that we've learned all of these principles, I'm gonna, as a review, put them all together and see how they would interact with one another. So for instance, to say that you were following a track line, used a running fix to find your position along that track line, changed course to create a new track, meaning you would have to DR out for it to be able to predict how far you would go ahead, get a new fix along that track, and then apply set and drift for all of it. And to show that all of this is something that you can, it's a rigorous system that you can use in any situation, all of these numbers I'm going to make up as I go along, just to demonstrate that they work no matter what, even if they might be a little bit weird as a result. So let's say that you're following this track line right here, and let's go fast. So we're going 18 knots along this track line this way. So at, let's say 12:10, we get a bearing of 190 from the Sandy Point light here. So you come to your meridian, you measure out 190, like so. You take your second triangle, you slide it down to Sandy Point light, and you plot your LOP all the way up, intersecting with your track line. There you go. And that's at 12:10, I believe I said. Okay. Now, at 12:20, you measured it at, you measured your Sandy Point light to be bearing 165. So you take your triangle again, measure an angle of 165, right there. Okay, there we go. Slide that down. Plot that. So that's your 1225 LOP. So now you have to advance your 1210 LOP to your 1225 LOP. So that occurred over a course of 15 minutes. So you do 15 times, I said we're going at a speed of 18 knots, divided by 60, 4.5. Okay, I overestimated how far that would go. So we're going to reduce the speed because, again, that was unrealistic of a guess for me. So we're going to say we're going 9 knots. So 15 times 9 divided by 60, 2.25. That's more realistic. So you measure a distance along your latitude scale of 2 miles, 0.1, 0.2, there's 0.25 right there. So 2.25 miles. You have it, you place the first tine where it intersects, where your original LOP intersects your track line. Place your second tine somewhere, wherever it lands along the track line. Make a little tick mark. Take a parallel line from your original and advance it over to the new one. Make a nice big line there. Your new LOP and your other 1225 LOP intersect right there at 1225. So that is your position at 1225. Okay, well, let's say, first of all, you're clearly way off track, but we're not going to worry about that because now let's say you decide to change course. You change course, it doesn't matter, to here, whatever this track line is. Actually, we'll label this properly, so we'll find out what this track line is now. But when you're voyage planning, you usually draw the track line first, wherever it matches. then you measure the angle of it. You don't need to say, oh, I'm going to go on course 220. It doesn't matter unless 220 actually works. So you usually will draw it first and then measure. So you draw it out, then you measure, you line up your triangle, move it over to a meridian, and you get, I don't know if you can see, you get 216. So this is a track line on course 216. So you draw your label, write C 216 degrees true, draw your arrow, and speed, we're gonna go with 9 knots. That's what we changed it to when 18 wasn't working. So we're going this way on a course of 216 at 9 knots. All right. Well, we were here at 1225. This track isn't really valid until we've laid out some DR positions. So now we need to plot those down. And let's use the 6-minute rule here because we are definitely in inland waters. So we want to use 6-minute DR fixes. So 6 minutes, 6-minute fixes going at 9 knots will mean that every fix should be 0.9 miles apart from one another. So you measure out 0.9 miles, you mark there's your first one, and that will be at 9 minutes later is 12:34. You mark your next one at 12:43. It's a difficult angle. And you continue to do this on and on and on as far as you need to it. A nice trick is to just spin the divider and do it again. Spin the divider, do it again. Spin the divider as far as you need to go. That's good enough. And then you draw the half moon over each of these, and you label them with the proper time. So 12:43, 12:52, 13:01, 13:10, 13:19. Oh crap, I'm an idiot. Where's my eraser? I've been adding you intervals of 9 minutes when these should be intervals of 6 minutes. So gotta erase all of those. The distances are still perfectly accurate. So it's not 12:34, 12:31, 12:37, 12:43, 12:49, 12:55, 13:01, 13:07, and 13:13. There we go. So there's your track line with your 6-minute DRs along it so that you can actually watch your progress. Now let's say along here, you get a composite range and bearing from Cow Cove or Sandy Point Light right there. And let's say you get a range and bearing. Let's say we're gonna do it at 12:55. So you should be here. You should be. Let's say you get a range or a bearing of 100 and a range of the 3.5 miles. So you measure out 100 on your meridian there. Move it over to Sandy Point Light. Draw out your line. There we go. That's your first LOP. That's your visual bearing, potentially radar bearing, but you should use a visual bearing from Sandy Point Light. And then you measure out your radar range from Sandy Point Light of 3.5 miles. 1, 2, 3.5. Right there. They intersect right there. But remember, that's not acceptable unless you get a third line of position. So you've got an arc, you've got a line. A third line of position, let's say you go down to this light, which is unlabeled, but it's the entrance to Great Salt Pond. So I'm going to call it Great Salt Pond Light. Let's say it bears, I don't know. Yeah, 309 or 311. So you measure out 311 right there, and you slide that over. And I'll zoom it in because this is useful to see. So you can see here's your LOP to Great Salt Pond Light. Here's your LOP to Sandy Point Light, and here's your range to Sandy Point Light. You can see they're not all actually going through the exact same point. That'll happen. There's a variety of reasons why. Maybe one of your visual bearings was off. Obviously, I was just making these up. I was trying to get them as close as I could. Maybe there's a little radar interference if your target was bad. It could be a variety of things. It could also just be the error in you plotting it yourself. What you need to know is that something this small, it's close enough that you can pretty confidently say you're right there. Like it's almost within the width of a pencil. If it was a triangle, like if it was that, and that would be no good because that's not useful to you. That's a pretty big margin of error. But if it's like that's okay. Your goal always is to get a perfect pinwheel like that, where there's an obvious point where they all intersect. But that's okay. That's definitely not okay. When you do solenoid for the first time, you're gonna get ginormous triangles, like triangles the size of your entire plotting sheet, and that's obviously not anything you can use. But let's say, so that's our position. You can just mark the center of it. The geometric center of that triangle is the closest you can get. Composite fix at 1255, right there. So you're clearly off track. So now you need to measure your set by connecting the dots from your DR position to your fix. You need to bring the triangle over the meridian so you can measure the angle. And then you measure the angle as, this looks like 221. So it's pushing you in the direction of 221. If you measure its distance, you bring it over to your latitude scale, 0.45 miles. So it pushed you 0.45 miles from 1225 to 1255, meaning it took 30 minutes to push you 0.45 miles. So if something takes half an hour to go 0.45 miles, how long would it take to go on a full hour? Or how far would it push you in a full hour? It would push you 0.9 miles. So your set is 221 and your drift is 0.9. Okay, that's good to know. Now you've got to account for it because you don't want to continue to be pushed off course. So you want to now find a new course to steer that will keep you going your original track of 216. So you take the direction of your set, you move it out in the opposite direction, take the distance of your drift, You plot that in the opposite direction. There you go. Mark a little tick there. Then you measure from your original fix at 1225 to the tick mark. There you go. And you measure that angle, which is, bring it to the meridian, 202. So your new course to steer from this position is 202, and that will keep you on your track so that you can continue to follow it and stay on course with 216. You are a little bit ahead of schedule, but you should be able to continue. Now, because you're over here now, you do want to actually plot a new track line, because you can forget about this old one, you're not there anymore. So you're still trying to follow the same direction. So you can measure 216, knowing that you have to tell the helmsman to steer course 202 for them to make good 216. But with that knowledge in mind, you can now plan to continue on track 216 from this position, going the same way. And if you're still going at a speed of 9 knots, you can still use the same 6-minute DR intervals and plot a new DR track line, or a new set of DRs along your new track line, because your old track line, let me correct that, slipped a little, that's fine. Your old track line is completely useless to you now because you're not there anymore. So all of that information is invalid. And this is the new information that you want to rely on to actually understand where you're going, so that in the future, if you take a new fix, you can calculate your set and drift and see if you're still on track. So that would now get you to, let's see, 1255. So 1301, 1307, 1313, and 1319. So that's your new track line. So to review, we were coming from over here. We took a running fix because we could only find one nav aid. So we took a running fix, one line of position, another line of position, advanced the first to the second in the same principles that you use for a DR, got your new position at 1225, set a new track line from there, labeled its course and speed, followed it along here with DR positions to monitor your course, got yourself a new fix using a composite fix of two bearings and a range from this one, found that you were off track, calculated your set and drift, used set and drift to calculate your new course to steer so that you could stay on track, and then using that information, plotted a new track line off of your new position to monitor your continued progress from there. That's how you actually apply all of these concepts so that you can use them to stay on track.